Hi, in this video, we'll go on to the modified duration. So in the previous video, we talked about the duration or the Macaulay duration, which expresses the sensitivity of a bond. So the higher the duration, the more sensitive, but it doesn't tell us how much of a change in the price can be caused by the change in the yield to maturity. So with modified duration, we can use a linear approximation to calculate that change in the price due to the change of yield to maturity. So just a bit of a reminder, we're using the same example from the previous video. So our face value is the same, 1,000. The coupon rate is 1%. The original yield to maturity is 5%, and the maturity is 5 years here. Okay, so let's assume that the yield to maturity has increased by 0.5%. So you can calculate the prices when the yield is 5% and the yield is 5.5%. So it's already been done in the previous video. So we're just going to show you here, so the different prices here. Okay, so we can know the accurate change in the price by comparing these two prices. So the accurate change is going to be minus 18.98 pounds. So in percentage wise, that's going to be at negative 2.3%. All right, so what can we do about the approximation of the change in the price so we can use the modified duration? So we're first going to show you the definition of the modified duration. We call it the D star here. Okay, it is simply the Macaulay duration divided by 1 plus y here. Okay, the y is the original yield to maturity, not the new one. Okay, so we can simply calculate the yield to maturity for this case, for this bond. Okay, so as for the duration, we've already done that from the previous video, which is 4.89 years. So the modified duration in this case is going to be 4.66 years. Okay, and then how do we use the modified duration to calculate the approximate change in the price? Again, I'm just going to show you the formula first, and we'll derive this formula in the next video. So the change in the price is going to be minus D star here, or the modified duration, multiplied by the original price of the bond and multiplied by the change in the yield. Okay, so we can simply plug in the numbers here. Okay, using the original price, the modified duration, and the change in the yield. So the change in the yield is going to be 0.5%. Okay, which is this part. Okay, and the modified duration, we already calculate that, and the price using the original one. Okay, using the original one. So the approximate change here is going to be 19.25 or negative 19.25, because we're increasing the yield, the price must decrease. Okay, so as you can see, there's a bit of difference here, but it's not too much of a big difference here. So it's not big of a deal. So in terms of percentage, so the change in the price in terms of percentage is going to be negative 2.33%. So that is a good approximation here, because we don't drift away from the original or the accurate number by too much. Okay, so the approximation works if the change in the yield is small enough. Okay, so why do we need approximation here? Because it's a shortcut. So if we want to change the yield, frequently, so it's not always 0.5%, it could be plus 0.3, plus 0.4, or any number between that. So we don't have to recalculate the price each time. We can use the approximation here to determine the differences, as long as the change in the yield is not too great. Okay, so we can illustrate if, in this extreme case, the change in the yield is too great. Okay, so instead of 0.5% of a change in the yield, we have 3% increase in the yield. So basically, we have 8% as the new yield here. Okay, so the new yield to maturity goes to 8%. Right? So still, we can compare two different ways, which is calculating the prices manually to get the accurate answer, or we can use the approximation and see if the approximation is a good one or not. Okay, so if we do the calculations here by the definition of the bonds, so the first time we would have the price when the yield to maturity is 5%, still going to be 826 0.82, which is the same as this one. Yeah, this is the same as this one. Okay, but now let's change it to 8%. Okay, then you can plug in the numbers again. Just by changing the 1 plus y or the discount rate during the calculation for the price, you should get the new price of £720.51. Okay, so that's the new price. So the difference in the price, the accurate difference in the price, is going to be minus £106.31. Okay, that's the real difference. Now let's take a look at what is going to be the approximate difference if we use the modified duration. So the modified duration tells us that the change in the price is going to be minus d star here times p times delta y. So we still have the same modified duration as this one, yeah, as this one, which is going to be 4.66, and the original price stays the same. And the only difference here is that this delta y here is no longer 0.5%. It's going to be 3%. So what's going to be the approximate change here? In this case, it's going to be negative 115.52. Now you can see the approximate change is a bit different from the actual change. So we can compare it in percentage-wise. The actual change, or the real change in the price, is going to be negative 12.86%. Okay, and then if we use the linear approximation, which is the modified duration here, the change is going to be minus 13.97%. So that's more than a 1% change, or 1% error, if you compare these two percentages. Okay, so the linear approximation in this case, or the modified duration in this case, does not work so well because the change in the yield to maturity is way too large. Okay, so now you should be able to calculate approximate changes in the price due to the change of yield to maturity using modified duration, as long as that change in yield to maturity is small enough. Okay, so when is it small enough? You will probably get that idea when you're given the question here. Okay, so according to the questions, you could, if the question tells you to use the modified duration, then use it. If it doesn't, then it's up to you. Okay, so in the next video, we will try to derive how do we arrive at the Macaulay duration, and how do we arrive at the modified duration, and why does it work this way. Okay, and I'll see you in the next video.